Before I talk about the hypothalamic pituitary connection, I had better go a little bit more into the idea of hormones. Now, this is a basic principle. When it comes to hormones. And that's the idea of a hormone being a long distance chemical messenger. Now, we saw that there was the exocrine system, and exocrine is going to produce products that aren't really signaling molecules, but more like digestive enzymes, saliva, sweat, oil. Okay? Whereas endocrine system is going to secrete hormones. And hormones are long distance chemical signals. Now, what do I mean by long distance? Okay, and this is where some confusion can occur. And part of the reason why other signaling molecules often end up getting discussed with the endocrine system, because long distance is a relative term. In this case, long distance can mean millimeters or even centimeters. Now, when we're talking about the endocrine system, we're talking about inches, feet, even a meter, because these hormones are traveling through the blood throughout the body. Now, let's see a couple different types of signaling molecules that often get discussed with endocrine. And the first one is a paracrine molecule. So hormones are those long distance. Paracrine chemicals are going to be shorter distance. That affect different cells. Different cells. So, for example, if I had some, let's say, immune cell that secreted a product, well, I know it's a gland, and this product went over and affected, say, a fibroblast. You can see that it's gone and affected a different cell. This would be an example of paracrine signaling or a paracrine molecule. It's a short distance. This is a nearby cell, and it's a different cell. Now there's also autocrine signaling. And autocrine signaling, or autocrines, are also short distance signaling molecules that affect the same cells. So, for example, if I had some cell that secreted some product, and that product landed right back on that same cell, this would be short distance affecting the same cell. Okay, let me give one more example. Let's say that I have a myocyte. Okay, and this smooth muscle cell produces some signal and it goes next door to another myocyte that has the receptor for that signaling molecule. Well, I know that I'm short distance, but am I paracrine or am I autocrine? Take a second to think about what this would be. Okay. This turns out to actually be autocrine. So, when I said that paracrine is short distance that affects different cells, I meant type of cells. And that's a common confusion between autocrine and paracrine. I meant type of cells. So if you said paracrine on this example, well, that's not accurate because this isn't a different type of cell. It's a different cell, but not a different type of cell. And here's the reason. This is local. These are the same cell type. If this cell is producing this chemical, under these conditions that this cell is experiencing, it's likely that this cell is also experiencing that same condition and producing that signal as well. And whether it lands back on itself or on a different cell of the same type, it makes no difference. If this cell has the receptor, it has those genes to make that receptor turned on under this environment. And there's no reason to think that an identical cell wouldn't do the same. So this is autocrine signaling. This is paracrine signaling, and this would be autocrine signaling. A lot of times these short distance signaling molecules get incorporated into discussions about endocrine because they work in so much the same way, except for they're not traveling long distances.